Sorry, my dog thought we had an intruder, so I had to go show him that no one was here. Okay, so anyways, so we've got that we're looking for 10 feet out, so 10 feet east of whatever this center point was. So we know 10, say it's approximately there. We know we're gonna have a point up top there that's about 10 foot out, but we're also gonna have a spot down here that's also about 10 foot out. Okay, and we know that 10 foot is in our x position, so that's going to go with our cosine stuff. So basically, we're trying to figure out at what time increments it's going to be 10 foot out from whatever the center was. So because the 10 is in the x spot with the cosine stuff, we're going to set that 10 equal to our cosine value here, and then solve for our t to find what the time value would be at those spots. So what I'm going to do is I'm just going to go 16 cosine pi t over 20. And then again, I'm going to set that equal to 10 because they're asking us 10 feet away there. Then I'm just going to solve that. So I'm going to start by dividing by 16 on each side. So then I'll have cosine of pi t over 20 is equal to 10 over 16, and I'm not going to reduce anything down until I get all the way to the end, and then I'm just going to type it in my calculator in one shot instead of trying to simplify and get decimals and stuff throughout here. So I'm just going to leave it like that for now, solve it out in one shot at the end. So then from here, working my way outside to inside, I want to get rid of that cosine next. So that means I'm going to have to do cosine or inverse cosine to both sides. So if I do inverse cosine over here, that'd be inverse cosine of 10 over 16. Over here, we know if we do inverse cosine, it's just going to cross that part out. If we want to write inverse cosine there that we're crossing that out with, we can. And then that's just going to leave us with pi times t over 20. Then from there, I would get rid of dividing by 20 by multiplying both sides by 20. So the 20s are gone. So pi t is equal to, I'm going to put the 20 out front there, so 20 cosine, or inverse cosine, geez Louise, of 10 over 16. And then to get rid of that last thing there, the pi, just divide by pi on each side. So that's gone, so my t will be equal to 20 inverse cosine of 10 over 16 divided by pi. And then, like I said, I'm just going to type that in one shot on my calculator so I'm not having to do a bunch of rounding. And here, I'm probably going to want to make sure that this is in, does it tell us what we're in? I don't think it tells us what we're in. So I'm assuming that we're in radians because it's got the pi there. Let's double check it with radians and see how that works here. So we've got 20 inverse cosine of 10 divided by 16. I'm just going to hit enter there for the top, get that number, and then I'm just going to take that and divide it by pi, and that gives me that my t is approximately 5.7. I don't know if it tells us what to round to. I don't see anything, so let's just go 0.70 seconds or something like that. So that would be our first shot here. Well, I guess it depends on which direction we're going. If we're going around this way, that would be in this spot here that it's going to take 5 seconds. If we're going the other way, like if we're going clockwise, then it'd probably be that spot. I'm just going to assume we're going counterclockwise because that's usually how we look at the unit circle. But that would be one of our answers there. Then what we want to do is we want to find what the other one is. To do that, it's kind of a little bit tricky, but what you want to do is you want to think, okay, we're dealing with seconds here. The full revolution all the way around is 40 seconds. So if we start here, go all the way around to here, it's 40 seconds. So if we consider this one our 5.7 seconds, and these are in the same spot on our, not really a unit circle because it goes out to 16, but thinking kind of like unit circle, that these from there to there and there to there would have to be the same distance away. So what you can do is if the whole way around's 40, you can do 40 minus the value we got here, and that should kick us out our other answer here. So what I'm going to do is I'm going to do the total amount of seconds, so 40 seconds, minus that 5.70 seconds that I just came up with. and that will give me, so if I go 40 minus, you can either go second answer, or you could type that one in there as well. But that would give me, let's go approximately equal to 34 point, that's going to round up to a 30 seconds. So about 34.3 seconds for our other t value there. Okay, and then we've got one more here. Okay, and this one is a little bit tricky. I actually had to Google this one to figure out what all to do here. Once I kind of figured it out, then it wasn't too bad, but at the beginning I was pretty confused. So here it says, consider the equation 6 cosine squared theta plus cosine theta is equal to 2. And they want us to find all the solutions between the interval of 0 and 360. So because that's 360 there, that's degrees. So before I do anything, I'm just going to switch my calculator back to degrees, just so I don't forget that. Okay, so then what you want to do here is, so basically you're solving this for whatever the theta is. The tricky thing is it's got cosine and cosine squared in there, so it's basically, it's like a quadratic equation, where like quadratics are, you know, something where it's kind of got like the U shape or like the parabola. So because it has that, we have to do our solving using quadratics. So like quadratic formula, which we'll do in a second here. So the first thing we want to do here is we want to take this equation, 6 cosine squared theta plus cosine theta is equal to 2. And we actually want to get this to where it's equal to 0. So if you remember, when we've solved quadratics in the past, you always want these equations to equal 0. So I'm just going to write a note here of what I'm doing. We got to get it to being equal to 0. Okay, so to get it equal to 0, we just got to get the 2 to the other side. So minus 2 from each side. So 6 cosine squared theta plus cosine theta minus 2 is equal to 0. And then from here, I was very confused on what to do. So this is where I went to, I don't know if I went to Photomath or Google or what I did, but what the internet told me is that they actually, to make this a simpler problem, instead of using cosine in here, what they do is they swap out cosine theta in each of these spots for just a letter to make it easier to solve. And the letter they used is t, so I'm just going to use t as well. So what they did is they swapped cosine theta out for just a t. So that's going to change to 6t squared plus t minus 2 is equal to 0. And again, I'm going to write a little note here that we use substitution, and we substituted cosine theta with t to make, oops, that's not how you spell make, to make it simpler to solve. Okay, so we just swap that out to make it a little easier to deal with. Then what you got to do here to find what these actual t values are, and usually there's multiple answers here, we have to use quadratic formula. So I'm just going to do that off to the side here, and I'm going to switch colors so you can kind of see where I'm doing quadratic. But I'm going to do quadratic formula, so I'm just going to write use quadratic formula to find solutions. Okay, and if you don't remember what quadratic formula is, that's where it's x is equal to negative b, or the opposite of b, plus or minus square root of b squared minus 4ac over 2a. And where the a, the b, and the c come from is when we're in this form, the a is always with the variable squared, b is always just with the regular variable, and then c is like our constant that's by itself, and you can only use this when it's equal to 0. That's why we got it to equal 0 first. So like I'm just going to write off to the side here, my a is 6, my b is 1, and my c is negative 2. And then we'll just solve that out using our quadratics. So we're just going to plug that stuff in there. So our x, or in this case technically it's t, but is equal to, our b is 1, so -1 or the opposite of 1, plus or minus square root of b squared, so 1 squared, minus 4 times our a value, which is 6, times our c value, which is -2, over 2 times our a value, which is 6. Okay, and then from there you just start simplifying your way down. So we'll have -1 plus or minus, and then I start simplifying under my square root there. So I'm like, okay, well, 1 squared is 1, minus 4 times 6 is 24, times -2 would be -48. So it would be minus a -48, and we know that's the same as adding, over, and then this is 2 times 6, which would make that 12. And then from there, we know 1 plus 48 is 49. So I'll have -1 plus or minus square root of 49 over 12. And then conveniently, square root of 49 comes out nice to be 7 and -7. So we'll have x is equal to -1 plus or minus 7 over 12. And then to deal with the plus or minus, you want to split it into two separate equations here. So one is going to be x is equal to -1 plus 7 over 12. And then the other one's going to be x is equal to -1 minus 7 over 12. So here this would be -1 plus 7 would be 6. So 6 over 12, which we know is the same as a half. So that's one of our solutions there is a half. And then the other one, same thing, so we'll go -1 minus 7, which is -8 over 12. And if we pull a 4 out of each of those, that would reduce that down to -2/3. So those would be our two solutions there for our, if you can see those. Those would be our two solutions for our quadratic. So then what you're going to want to do is you're going to want to take those guys, put them back up here into our original equation where we were like solving for those actual t's. So that would tell us our one t is a half, the other t is -2/3. So basically so we got what those values are. But now because we use substitution here and pulled that cosine theta out and switched it to t to make it easier to get those values, now what we have to do is we actually have to sub that cosine theta back in for the t. So I'll write a little note here. So sub cosine theta back in for t. So now instead of t equaling a half, we're going to have cosine theta is equal to a half. I'll split this into kind of two sections here. And then we'll also have cosine theta is equal to -2/3. And then we know to solve for each of those, what we would do is inverse cosine. So we'll do inverse cosine of a half to figure out our theta. And then we'll go same thing here, inverse cosine of -2/3 is equal to theta. And then I would just use my calculator to figure out what both of those are. And we already switched it to degrees, so it should be good. So I want to go inverse cosine of a half, which gives me 60. So here my theta will be 60. And we're in degrees. And then here, same thing, so inverse cosine of -2/3, which is 131, so approximately 131.81 degrees. So then from here, what we actually have to do is we have to do the same thing we were doing before here when we had the sine stuff, is we have to include our second values here. So this one, because it's kind of a different style of equation, you're actually going to have more than just two solutions. You're actually going to have 4 solutions because you're going to want to take each of these thetas we just found, and you're going to want to do the 2 pi minus those thetas, or in this case 360. So you're going to want to go 360 minus your 60, and those are both in degrees. which would give you 300. So 300 degrees is also an answer there. So you got 60 and 300. And then that's one of our answers, the 131.81. And then you're also going to want to do there 360 degrees minus that 131.81. And figure out what that is. So I've got written down that that's 228.19 degrees. So that would also be a solution. So in this case, because it's not just like a standard equation, we had multiple solutions there. So we got that stuff. Then for B, what they want us to do is they want us to do that general equation stuff where we're taking here, since it's cosine, we're taking 2 pi n or 360 n and adding it to each of those answers we just got. So you're going to do like theta is equal to 60 degrees plus 360 degrees n. And then we'll also have theta is equal to 300. So that was another solution there, degrees plus 360 degrees n. And then we'll do that same thing for those decimal ones there. So theta, I'm going to go approximately equal to, since I did my rounding there, 131.81 degrees plus 360 n. And then our theta is also approximately equal to 228.19 degrees plus 360 n. Okay? So a whole lot going on with that problem. We had to do quadratic, and then we had to do all this extra new stuff with the general solution stuff. But that's kind of the main gist of that, okay? So finding your stuff and then figuring out if it's cosine or theta, or cosine or sine or tangent or whatever. And then your general solutions is just taking whatever your values were and adding either 360 n or 2 pi n, or in tangent case pi, or 180 n. But yeah, that's kind of the general gist. Okay, so your book page assignment here is page 329, 3 to 14.